Hello grade 10, this is Miss Hughes
And this is Miss OG.
and we're just going to talk you through an investigation. This is from one volunteer from grade 10, just to look at the kind of quality we are expecting. This is the formative task, which was House of Cards. We apologise for the quality of the scanning. This is the best we could do, but hopefully you can follow as we go through it. Starting with the title, it's relevant investigation of a House of Cards.
Okay, so after the title, we'd like to see some sort of introduction. So if I just read this to you just so you can read it. We have been given a task to find out how many cards we will need to make a 10-story house of cards. On the information that 15 cards make a 3-story house. I will try and find the formula by finding if there is a pattern with adding stories. So it was quite a good, nice, short, concise introduction. Talks about the information they're given and what they're going to try and do in the task. And then, then it also says cards are Y and story number is X. Now this is good. We should always define our variables. However, what also we would like to see is just a quick sentence about which one is the dependent and which one is the independent variables and why. So in this case, the story number is, oops, sorry, Miss Hughes. The cards is the dependent variable, and X, the story number is the number of, is the independent variable.
Correct. Because we can choose the story number we want. We don't necessarily choose the cards. And we probably want to see the word variables in there.
Yes, yep. Correct. We want to make sure we get all those communication points as well. Okay, you're going to talk us through, Miss Hughes, how we can find this formula.
Yep, okay, so this student has done the right thing of actually sitting and actually drawing the first 5 diagrams. They're fairly clear, and they've labelled them, which is really good. This saves the reader having to sit and count. It's good for communication points. And they haven't just put 1 and 2, they've put 1 story, 2 cards, so good points there.
Good.
They've then put their data in a table, which is fine. Maybe just for communication, it would be good to just tell the reader, I'm now going to put my results in a table of values. Okay, so this student has used the method of differences. They've looked at what the numbers are increasing by, and they've noticed that it's the second row of differences that is constant. They then use this to find that the coefficient for x squared is 1.5. Now this is good, but we're looking for just a little bit more in terms of vocabulary and communication. So these two, for example, should probably be labelled first difference and second difference.
And how do we know that the coefficient of x squared is 1.5?
That is a good question, and we would have liked them to have said, first of all, that because it's the second row of differences that is the same, that is constant, this means it's a quadratic formula. So that's our first point of information. Because it's the second row of differences, second column of differences that's constant, it's got to be a quadratic. And that number needs to be halved in order to get the coefficient, because the second difference is double the coefficient of x squared in the formula y equals ax squared plus bx plus c. If you're generalizing, that number is double the coefficient. Yeah?
Ah, okay. That makes sense
now. So they realize that it's something to do with 1.5 x squared, so they've correctly listed 1.5 x squared. They've got the spreadsheet to do the work for them. And then they've actually subtracted this sequence from the original. And these are the numbers they're left with. They call them leftovers, which I think is fine. Any other way we could describe that?
I think leftovers is okay.
Leftovers is fine.
Or even to write y minus 1.5 x squared.
That would be a good idea. Y minus 1.5 x squared. Okay. The fact that, again, they've looked at the method of differences, and we would probably have liked to see a comment. It's the first set of differences that is constant, therefore this is a linear part of the sequence of the formula. And they're going up, the increase is 0.5, so it's something to do with 0.5x, and they've actually realised that it is 0.5x. So again, just a little bit more explanation of where this part of the formula came from. But overall, they came up with the formula that it's comprised of 1.5 x squared combined with 0.5 x squared. It would have been okay to also write this as in fractions, so that would be fine, x over 2.
I would also like to see that be equal to y, seeing as y was already defined as a variable.
Yep. So then we have a nice formula to finish. We could also factorise, I guess. They could have written x brackets 3x plus 1 all over 2.
Yep.
That's an option as well.
Of course.
Okay, right.
Okay, so then the actual task did ask to find how many cards are needed for 10 stories. So the formula's been stated, and they've said to work out the 10 stories, I will need 155 cards, and then below they have given some sort of justification of that. So first of all, they've substituted into the formula and got 155, and then they've checked this by then just extending the table and just purely following the pattern that was noticed in the first place, that the first differences were going up by 3. And then they've justified it even further, which is really nice, by drawing the diagram for 10 stories. So that's a good verification, I think, that the formula seems to work.
I probably would add at this point, it's probably worth doing, for your own benefit and for communication benefit, once you've got the formula, it's probably worth checking with a case that you've got already. So just a quick check. Maybe check that if you replace x with a 5 in your formula, that you do actually get 40. So just do a quick check with the values. Yep. Now the one thing that's missing here is to actually state, even though it's to actually state the obvious, to state that because by the table and by the diagram, it shows that my formula is correct. Very important statement, that formula is correct. Okay, so shall we say roughly what this person would have got for their grade?
I think it has a lot of good things about it. And the one thing that it probably is missing is the level 7 and 8 criteria. So I think it would definitely get a solid 6 for the B criteria.
Yeah, the 6 criteria says that they've actually found the formula and they've verified that it's correct.
Yeah. Yep. And then for communication, there was a little bit missing. So I think a 4 for communication out of the 6. If there was a bit more words just explaining each step, then definitely the 5, 6 is a possibility there.
Yeah, so for a 5, 6, we're looking for you to state the obvious and also to use all the correct vocabulary and not miss any of the key words out.
Yeah.
Now what we'd like to do briefly is just show you some ideas of how you could have got the 7 and the 8.
So one of the things that was missing, and that is in the criteria, is to get a 7 you need to discuss the limitations of the general formula. Because of course we can't just use any old number in our formula. And to start with, if we look at the, I used n in this case, or x, the one that represents the story number. We have to start with 1, we can't have less than 1 story. So x or n has to be greater than or equal to 1. And it's important to remember that it can't be a decimal or a fraction. So x or n or whichever letter you choose has to be an element of the integer set. So whole numbers. Then if we look at the number of cards needed to build each story, so in this case C, or in the example we just showed Y, that has to be greater than or equal to 2 because we needed 2 cards to create the first story. And again, the Y or C has to be an element of the integer set of numbers.
Okay, so that would have got you a 7.
Yep.
And then for the 8, this is the tricky bit. There's several different ways of approaching this. It's basically, to get an 8, you've got to try and mathematically prove or mathematically show, well, why is the formula what it is. Mr. Dees has found a good, fairly straightforward way. Do your best to follow it. It does involve you understanding, remembering about triangle numbers or Gauss, remembering to how you add numbers 1 to 100. So for example, 1 plus 2 plus 3 plus 4 plus 5, all the way up to 100. So if you're not sure about that, you'll have to look it up.
Okay, so what I did here is I broke down each story, I pretended that I had an n-story house of cards, and I broke down each story in the house of cards. And I said, okay, well, on the top story, or if I call that still the first story, I have 2 cards. And then on the second story, I noticed that I have 2 lots of those same 2 cards that I started with. So I need 2 cards to make one little triangle in the diagram. And then in the second story, I have 2 of those triangles. So that's where the red triangle is coming from in my numbers on the side there. And then I needed to add 1 to get the horizontal one so the top story could rest on it. Then I just extended that for the third level down, and I notice I need 3 of those triangles. So to make 1 triangle, I have 2 cards, and I have 3 lots of them to make the 3 triangles, and I need 2 of the horizontal. And then I just extended that, and then you can read for yourself for the 4th story. And then tried to predict then what would it look like on the nth level of this house of cards. So on this level, I noticed a pattern that it's always the story number, that is the red number, times 2 lots of 1, or just the 2 times 1 cards. And then it's what I add on is always 1 less than the story number. Okay, there it was story number 4, but I added 3. There it was story number 3, but I added 2, and so on. So I said, okay, on the bottom row of this house of cards, I would have n lots of 2 plus n minus 1. Now to get the total though, that's just looking at each level on the story. So then I need to look at the total number of cards I need.
And I think the last page hasn't scanned, so we'll talk you through it.
So what we need to do is we need to just add them up. So I had on the top story 1 lot of 2 plus 0. And then on the next story I had 2 lots of 2 plus 1. And then I had 3 lots of 2 plus 2. And then if I go to the last one, I had n lots of 2 plus n minus 1. So then we need to actually work out, well, how can we add all these up? So then I looked at it and thought, what if I break it up into 2 additions? So I took the lots of 2, so 1 lot of 2 plus 2 lots of 2 plus 3 lots of 2 plus n lots of 2. I grouped those together because they were all just being added together, so that's okay. And then I added separately, then I grouped all the bits that I was adding on. So the 0 plus 1 plus 2 dot 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 plus n minus 1. Okay, and then I took out, for the first part there, I took out 2 as a factor. So I had 2 lots of, and then inside I'm just going to have 1 plus 2 plus all the way to plus n. And then just the 0 plus 1 plus 2 all the way to n minus 1. Then I had to think of a way, well, how could I add up 1 plus 2 plus 3 plus 4 to whatever n was? And then I remembered about triangular numbers and about the rule that Gauss says that if I have, for example, the numbers from 1 to 100, he came up with the nice little way to do this and said, well, okay, let's add the first and the last. So when I add the first and the last, I get 101. Sorry. And then if I add the second and the second last, so 2 plus 99, I would also get 101. And then this pattern continues. So every time I add the first and the last, the second and the second last, etc., I always get 101. So I know 101 has to have something to do with it. And then I thought, well, how many pairs? He said, well, how many pairs would you have that would add to 101? So then, well, there are 100 numbers. But I'm pairing them up, so that means I have 50 actual pairs. And 50 comes from just 100 divided by 2. So then using that idea, I said, okay, I add the first and the last, so I have 1 plus n, or n plus 1. And then I'm going to have lots of pairs of those, and I'll have n divided by 2 pairs. Then I did the same thing for the 0 plus 1 plus 2 to n minus 1. And I add the first and the last, so I get 0 plus n minus 1 is just n minus 1. And again then I'm going to have half of the number of that I have. Because I start at 0 and I go to n minus 1, I still have n numbers there. And so I divide the n by 2. And then I just played with the algebra. I can cancel out the 2's there. Because I'm multiplying each time, it's okay. So I've got n lots of n plus 1, which expands to n squared plus n. And then I expanded the second bracket to n squared over 2 minus n over 2. And collected things the same. So I had n squared plus n squared over 2, which is 1.5 n squareds, or 3 over 2. And then I had 1n minus n over 2, which is the same as 1n minus a half n. So you get n over 2. So that justifies or proves that my formula must be correct, because it shows that it will always work. Doesn't matter how many stories you have.
And that would have been an 8 in criteria B. Okay, so use this to help you, and good luck.
Yep, good luck. Bye.